All right, hello everyone. Today, this is the second week of the Energy Conversion Laboratory. Before I talk about the simulating that you can find in Canvas, I want to highlight some feature about the PV and demonstrate something here. First of all, I want to talk about the IV curve, which is the red line in here. Now, the IV curve represents 2 points. The first point is the open circuit test, which means the BV, you apply no load to it. That means you open those two lines and measure the voltage. In this case, it's going to give you the maximum voltage. It's going to give you the VO, the voltage open circuit test. And the second one is you apply the maximum current or the maximum load to the BV, and you see uh, how much current is going to give you. It's the current short circuit test. Basically, you short circuited the two terminal and you're going to get the maximum current. Now, this is the operating for the BV. If you multiply the voltage with the current, you're going to give the BV curve. And we're trying to get the maximum power point in this case. Now, here's the point. So you can configure the BV to connect it to the load directly, like a water pump in this case. If the water pump need maybe, let's say 50, and your maximum point is 100, see, there is no point you're gonna get just 50, as long as you are in this line. Now, if you are connected to the grid, yes, you can give 50, whereas the remaining 50 gonna go outside to the grid utility using DC converter and DC AC converter. We'll see this in the simulator. Also, you can connect it to energy storage devices or energy storage unit, which you can use the 50 watt, and then the second 50 watt you can store it or sell it to the utility company if this is located in your house. Now, the cell has the BV has three things: the cell, which is used to create the module, and the module is used to create the area, as you can see in this figure. Each cell has 0.5 voltage. Now the cell, you can connect it as you learned in the circuit one. You can connect them in series, so you can increase the voltage. This is the curve, the new curve, the curve for module 1, 2, and 3, all of them combined. Or you can connect them in parallel. In this case, you increase the current, which is the sum of the current for all of them. If you are interested in both, you can connect them in area in this case. So you can increase the voltage and the current, both of them. Depends on your application and how much current, how much voltage you need. This is it. Now let me talk about the simulating. So I provided with two. The first one is a simple. This is the BV connected using the diode, and the diode connected to the load, emulating the load. And the load is variable. This is to change the load value. Now this is the irradiance, and this is the temperature. If you double click on the BV, it's gonna bring you with this. If we look plot the IV curve, you can see the IV curve in this case. Now the maximum curve in this case is about 8, I would say 8, right? 7.6. Now if you increase it to 2, it's gonna increase the current. That's in parallel. Now let's bring it back with this. Now you put back the current, but you increase the voltage from 60 to 8. Let's see here how much it's gonna give. I don't think it's gonna give anything. Yeah, 67. Now if I put it back, plot it again. Yeah, let's go back. Let's go back. Now, this is, you can choose the temperature. You can assume where you're gonna live. Let's say you wanna live north or south or whatever, like the temperature is. Look it up and see the minimum and the maximum, put it in here. And then let's say the maximum is 25 and the minimum is 45. Just plot it, it's gonna give you the two temperature, 45 and 25. If you add another one, let's say 4, it's gonna give you the 4 here. Please play with it and see what's gonna give you. Also here, you can choose the irradiance. This is the irradiance. You can choose the irradiance and plot it and see how much it's gonna affect your power output, as you can see here. Now this is it for this. Now we want to see the curve. In order to see the curve, you want to use the bus selector. Please do this and take screenshot of it. Double click in it. Double click on it. Remove this. You don't need it. So we need the V and the I. Apply and go double click and look for scope. Put it here. We're also interested in the product because we want to multiply current and voltage. We want to connect the current directly here, whereas the voltage here and here. All right. Now double click on here and type power. If you run that, and this is it. Let's split this and click in here to show you. Here you can see the power and the voltage, the current over time. All right. So this is for the first one. And the second one, what we're gonna do, we're gonna measure the voltage input. We talked about the DC-DC converter in the slide. This is the DC-DC converter. It's gonna give you whatever power it's gonna take from. This is the emulation of the BFE. We assume this is a source. We provided the voltage profile. It's gonna vary from 50 to 80. And this is will be given to the control voltage source. The control voltage source, it has 0 frequency. That means it's a DC, not an AC. I know the sign is here. It's AC. This is just to enable it. You can, if you want to disable, you can change it to 1. And this is the control for the duty cycle. The output is the load. We're emulating the load. Now let's do the control and see how this is going to affect. We can say voltage measurement. We need to connect the voltage in here and the voltage to terminal. And also we're looking for go to connected. Let's name it voltage in, which is the voltage going to the boost converter. And here go to. Also, it's the voltage going out of the boost converter. So the control need a feedback. So I'm going to take a feedback and give it to the control. So it can monitoring the output. I'm going to look for a scope to plot my result. For both the in and out. And run. If you see here, let's maximize. So this is the input. Well, actually, take it out, type here, voltage out, double click on here. voltage in, run it, load it, and here we go. So the voltage in is this. It doesn't matter how much the voltage going to the boost converter, it's gonna maintain 90 volt. Now 90 volt is the reference given here. I can change it to 100, apply, then bring back this and run it again. Let's see how much it's gonna get. 100. This is the reference. It doesn't matter what is the voltage in the output. This is the simulation real-time scenario. There is limitation, but this is the constant. So please do this, do the calculation of those and take a screenshot and provide it in the simulation beside the question in the PDF or in the assignment. Thank you.